Alright, here's another problem from the homework. We want to know what the volume of 0.05 moles of nitrogen monoxide gas is at STP. So I'm looking for volume. And I've got 0.05 moles of nitrogen monoxide, so that's going to be N for moles. It makes perfect sense, right? So 0.05 moles. And then it seems like that's all the information that we're given, except that we have to remember that STP stands for standard temperature and pressure. At standard temperature, that's going to be 0 degrees Celsius, and standard pressure is 1 atmosphere. But since we can't use Celsius, it's just going to be 273 Kelvin. So by writing STP, that's just a shorthand way of saying our temperature is 273 and our pressure is 1 atmosphere. So even though it doesn't look like it, we do have more information on this problem. So pressure, 1 atmosphere, and temperature is 273 Kelvin. And this problem is what we call a steady state problem. It doesn't involve changing anything. It doesn't say what's the new pressure, or the new temperature, new volume, or when we change this, we get this. This is just saying, here's some information about this gas. What's a piece of information that you can give me? So we go shopping for our formula. We've got P's and V's and N's and T's, and we might see a formula that looks like this. PV is equal to nRT. So this is 1, 2, 3, 4, 5 things. We only have 4 things. We're missing a 5th one. The only letter that's not there is R, and that's our ideal gas constant. That will always be 0.0821. And the units for this are liters, atmospheres per mole Kelvin. A lot of people think these are things to plug into. These are just the units. If I have any sample of gas and I take its volume and its pressure and divide it by the number of moles and its temperature in Kelvin, I'm always going to get this number. So that's our ideal gas constant R. So I'm going to clear out some space over here where I wrote our STP info, just to make some more room for us to do this problem. There we go. And now I'm looking for V, so I gotta get V all by itself, and the best way to do that is divide each side by P. So our pressures cancel, so V is equal to nRT over P. And now we're ready to plug some numbers in. Our temperatures in Kelvin. The other thing we have to worry about here is whenever you're using this value for R, our pressure units have to be in atmospheres. Luckily for us, our pressure units are atmospheres. Our volume units have to be in liters. Well, we're looking for volume, so when we do that, our units will be liters. So now we're ready to plug these numbers in. So V is equal to 0.05 moles times my ideal gas constant, 0.0821 liters atmospheres per mole Kelvin, and then my temperature, 273 Kelvin, and then we're going to divide this all by my pressure, which was 1 atmosphere. Alright, let's take a look. I got moles on the top and I got moles on the bottom of the top over here, so they're going to cancel. I've got Kelvin on the bottom of the top and Kelvin on the top of the top, so they're going to cancel, and I got atmospheres up here and atmospheres down there, so they're going to cancel. The only units that I've got left are liters, so this is a good sign that whatever this comes out to be will be my answer. So I'm going to multiply this, let's see, 0.05 times 0.0821 times 273, and then I'll divide that by 1, but I don't really have to do that. That gives me a volume of 1.12. My units, like we said, the only one left are liters. So this is your simple, maybe not simple, but your basic, uncomplicated. The only tricky part here is knowing STP is 273 Kelvin and 1 atmosphere pressure. Just your standard ideal gas law problem.